Hello and welcome. I'm David S. Read, CTO and Innovation Leader at Blue Slate Solutions. And I'm Whiteboard Dave, MEU at Blue Slate. MEU? Yes, I'm the maker of the esoteric understandable. Right. Well, we're here today to talk to you about our concept of a cognitive corporation. A cognitive corporation for us is a vision around operating a business in a way that the IT investments and the people and processes are leveraged as effectively as possible. We want to get the most value out of those pieces as we can. A cognitive corporation, by using the word cognitive, is about the fact that the entity itself can think and learn. We have tools that make us more agile, but we need the ability to leverage that agility and actually make changes to processes, rules that are running, and things of that nature. So that's the concept of being cognitive. Now, I want to start off with the fact that this cognitive corporation vision that we're talking about, it's not a product. It's not hardware or software that you can go out and buy. Rather, it's a way to think about your current investments in IT and the people that operate those systems and use those systems, and leveraging them in a more holistic manner that allows you to extract value from those investments. It also allows you then, once you understand how those investments are being used, to look for targeted opportunities to invest in new components that have a specific ROI tied to them. We'd like to start talking about the cognitive corporation by going through a framework that we use to communicate how it works. The framework itself is used to organize our systems into their basic functionality. The 6 areas that make up what we consider to be a cognitive corporation are the ability to think, the ability to communicate, the ability to take action, the ability to store knowledge, the ability to sense change within an environment, and finally the ability to learn. Those 6 traits allow a living organism to function within a changing environment. In a business environment, it allows a company to adapt to those changes within its environment. Now, you'll probably recognize that some of the technologies that are located in each of these areas, and that's on purpose. The idea is that companies invest in components such as business process management tools and business rule management tools in order to carry out some automated function or give themselves some kind of agility. In that case, those tools are used to take action. We create workflows and we create decisions that we want the system to take on our behalf, and those systems do that for us. We invest in databases which represent knowledge. We build data marts and data warehouses. We build unstructured data and place that in content management systems, but it's all about storing our information. And another major area here is the ability to learn from that. We've got all this information. We have all these processes. We want to know when those processes should change. When are we doing something inefficient? When are we making decisions that are incorrect? We can use analytics to help determine when those things are happening. All right, less biology, more about business. You've heard that we use the cognitive corporation framework to actually help understand your current systems, make better use of them, and be able to make investments, informed investments that lead to ROI. But exactly how do we use the framework to do that? So let's walk through it. The first step is we take a look at your infrastructure, at your applications, at your processes, and map them out. Nothing unusual about that. You've probably seen diagrams like this many times. It shows each of the systems and where the data is and who's using them. And we essentially create a baseline. The next step is we take this cognitive corporation framework and the functions defined within it based on your business model and come up with a scorecard that we can assign weights to. Those weights are based on your business. They're not generic weights. It's what's important to operate the type of organization that you're operating. And so, for instance, we can see that we take the areas, and the actual scorecard would have more areas on it, and list out how important those are to the operation and focus and strategy of your business. That scorecard is going to inform some downstream activities. The next thing we do is take that baseline we created and map it into the cognitive corporation framework. So now each of the applications, each of the databases, each of the other functions that go on is mapped to be inside of that framework. So for instance, we can see here that we've got some interfaces that people use, Those go into the think category. We've got some applications that actually make things happen, have some workflow inside them, probably hard-coded rules, and those are part of the act category. And then we've got databases, and those are part of the know, part of the knowledge base. So now what we've got is a scorecard that says how important are these concepts to the operation of your business and your strategy and your current systems. From that, we can create a report card. The report card tells us which of your systems perform what role and how well is it performing that role based on how important that function is to your business. What's nice about this is that it gets us what we call an actualization score. The idea of the actualization score is that if your systems do exactly what you need, then you'd be 100% actualized. If you're thinking of it as a report card, you'd have an A. Anything lower than that says that there's some opportunity to have the system and the processes do a better job for your business. So we can see the actualization scores get calculated, and what that does is tells us which areas would it make sense for you to invest in, and which areas, which types of applications or functionality is meeting your business need, or at least doing better than other areas. Once we have that understanding, we can build out a future state. The future state is an architecture that leverages your current assets and integrates into them pieces that will improve the benefit that you get from them. So for instance, if the report card says that there's a weakness in the act area, meaning that there are certain business processes or business rules that you would benefit from automating or from placing in a tool of some kind for agility, then that score would be low. So here, for instance, it has a 9. But we see that the knowledge area has a score of 53. So from that, we know that it wouldn't be worth investing a lot of effort down in the knowledge area with this gap in the act area. So what the blueprint is going to do is walk us through a process, a set of investments and improvements that we can make in an order that leverages this report card to decide which ones are worth putting the effort in to start. So that's how this process actually works. That's all well and true, but we're missing one very fundamental part of what makes this work, and that is the idea that information needs to be shared between these components. We have to integrate these components and have information move around in order to give them any kind of value. If the BPM tool simply works on its own set of information, it's not particularly useful. It will need to go out to our system of record and pull data. The way that's normally done when we integrate systems, and traditionally for many years, we've told these components where to find the data they need, and we call that location-based integration. So for instance, we will tell the BPM tool to go reach into a certain database and pull a certain field out of a table. But the BPM tool doesn't know what that piece of data is. It doesn't understand its meaning. For that, we need what we call semantically based integration. We want the system to not pull a piece of data because it knows where it is physically. We want it to pull it because it knows that it needs that piece of information based on its meaning. So for instance, if the BPM tool needs to display a first name, it should be asking for a first name out of the environment, not something in column 3 of table 5. That semantically based integration is supported by a set of tools and technologies that have been created over the last 10 or 15 years. You've probably heard of something called the semantic web. The semantic web is a concept around letting machines interpret data rather than people. That semantic web itself is based on a set of semantic technologies. Those technologies you may have heard of, they're things like semantic reasoners, RDF.
Hold on. I'm doing you a favor, folks. He's about to start going on about ontologies, semantic reasoners, W3C standards, and ultimately invoking the name of him who thought it all up. And I'm not talking about Al Gore.
It was Sir Tim Berners-Lee who in 1999, after inventing the World Wide Web, said the next logical step is to allow computers to directly understand the information that's moving around on the internet, not just people. And this led to...
We get it. Really smart guy, thinks about how computers need to be able to understand data, a bunch of standards are created, companies create solutions, big and small, that integrate all this information. But so what?
It means that information is federated across the systems and the meaning maintained as it moves around.
Too much theory. And by the way, federating is just a fancy way to say integrating.
Let's take an actual look at how this works. Let's say we have a user interface. Maybe it's generated by your business process management system or an application that you've written, but a user will need to interact with this. They're going to read data from it, they're going to update data within it. And then you've got a database that is collecting the information that this user interface uses. This idea of location-based integration is really just the way that we map between these two. Typically, the way that you get the system to access the data is writing a set of SQL statements. Those SQL statements tell this system what server and what table and what column within that table and really what row to go fetch all this information from. But it's a location. It doesn't tell it go get something by the meaning of it. So let's drill into this more specifically. Let's say that you play the part of a business process management system, and you are generating this screen, and I'm telling you what you need to do. And just for instance, let's say that this data is actually sitting here in Klingon. Really? What? Star Trek? You're gonna go all geek on us now? I think this will actually work quite nicely. Now imagine that I've asked you, as the application or the workflow system displaying the screen, to please go get some data from the database and place it here. So I've asked you to please take the information in column 1 and display it on the screen in this location. Take the information from column 2 and place it here. You, as the system, will oblige, and you will very politely place that information on the screen. The issue is that only the person looking at the screen can interpret what this means. You, as the system, are completely blind to what you just did. You don't understand the meaning of this information that you've displayed. Is this like distance to firehouse data in one of these columns? You just have no idea what the meaning is. And that's the issue with location-based integration. The systems aren't actually participating in the meaning of the information. They're just moving zeros and ones around so that people can interpret it. And it's very difficult to automate that in a meaningful way. That's why semantics are so important when we talk about integration. Fascinating metaphor. I think drawing an ontology might be more useful. Luckily, I've got control over the whiteboard, and I'm not going there. Folks, you owe me yet again for saving you from another tedious lecture. Fine. But we should move on and explain the value of integrating all this data and what we're going to do with it. For years, we've been using analytic tools against our operational data stores. We've been building predictive models and reporting systems that help us understand what we can learn from this information. What's really nice is if we start to integrate the information from these environments, such as our business process management and business rule tools. These produce what we call behavioral data. So we've got operational data in our operational data stores, but there's behavioral data in these systems. And by combining that information and leveraging it within the analytic environment, we can get much more interesting information about what's happening within our environment. Esoteric alert. Enough theory. Let's look at an actual business example of how this works and discuss what we mean by behavioral and operational data. John has bought a house. Wouldn't it be easier to call him Dave? Look, it's bad enough talking to myself. I don't need to be talking about myself. Anyway, John has purchased a house, and he knows he needs homeowner insurance. So he whips out his phone, goes to Google, and types in homeowner insurance. Google brings up a set of links, and one of them is to your company's website, and in fact to the form for your quoting system. He brings up that quoting webpage and fills in the information and clicks the quote button. That information that was collected gets written into a database. That is your operational data. That's the information that you need in order to understand your policies and your policy holders and all the relationships within that information. You need that. But that's not the only thing that happened when he pushed the quote button. It also started a process. Now this process could be encoded in an actual business process management system, and the decisions could be encoded in a rule system, or they could be code built into an application that you've got running on a web portal, written in .NET languages or Java, something like that. But one way or another, there's an orchestration of steps that runs when the user clicks that button. And so John's request goes into this system, and your system makes decisions. Those decisions might lead to the request needing to be passed to an underwriter. It might be that it goes out and looks at this location, the address, and figures out how close is it to the coast because it wants to do a risk rating and come back with an actual quote amount. So the system runs through this process and executes these rules. Now you can actually store that information about what steps something went through, what decisions were made. You can write that into a database, and that becomes your behavioral data. Now what's really cool and powerful is that the same way we like to create predictive models and look at the system in terms of the operational data, we can use the same analytics, the same data mining techniques with the behavioral data. And what's really powerful is when we combine the two and start looking at the operational data and the behavioral steps that the system went through to arrive at that data. And then we can start to produce models. Now, we produce these models with operational data. We get results such as, oh, you've got a bunch of policies that are paying at this amount, and maybe we've got a risk issue. If we combine it with the behavioral data, we can start to model and find things like, oh, this workflow process isn't working efficiently. It keeps making the same decision at this point. Or it always makes this decision, and then within a year we end up paying out this much. So we're seeing that there's some relationship between this decision point and risk being too high on these types of policies. We can start to find those patterns. That allows us to then send that information back and modify the workflow and modify the rules. And that is very powerful. I hope you've enjoyed this introduction to our cognitive corporation concept. The idea is to take advantage of your current investment in IT assets, understand the functions they perform, and optimize the way that you use them, and at the same time look for targeted opportunities to make additions into that architecture to add features such as learning and agility. We do that through what we call a blueprint, and as we've shown you, that blueprint walks you through a set of projects that each iteratively builds upon the last and adds these features in a way that's based on what's important to your business. The key concept is the feedback loop. All the information, operational and behavioral, can be fed in to analytic tools, data mining tools, models built, and the information communicated to people who can start to understand where opportunities lie. Those opportunities give you the ability to reduce your costs, improve productivity, and ultimately to look for other strategic opportunities in your business that your agile environment will allow you to capitalize on. All these concepts, business process management, data mining and predictive analytics, and semantics, all play a key part in building that one vision, creating a cognitive corporation. Thank you for watching this video. If you're interested in speaking more about these concepts, then let's talk.